Hello everybody. So in this video, we're going to look at the eccentricity of a hyperbola. So we have our hyperbola here and the negative side here. And from the hyperbola, we can have a point. And this point has coordinates x and y. And we can connect this point to the focus point with the coordinates a, e, and 0. And the perpendicular line runs to the directrix, which we'll call PD. And the focus directrix property of a hyperbola is that the distance p to s will equal the eccentricity value e multiplied by the distance p to d, where e is greater than 1 for any point on the hyperbola. And we're going to prove this property of hyperbolas. In example 1, we've been told to consider 1/2 of a hyperbola and using the focus directrix property to show that this is true. The first thing we're going to do is we'll use the property PS is equal to E times P to D. So now we need to work out the length P to S, but we can think of this as a right angled triangle, where we can use Pythagoras' theorem. So to work out the length P to S, we can work out this length, which will be the x value at the focus point, A to E, minus the x value at the point, so AE minus x. And the perpendicular height of our point will be the y value. So P to S then will be the square root of AE minus x all squared plus y squared. And we can work out P to D. This will be the length from the point to the directrix, which is the same as the x value at the point minus the distance from the y-axis to the directrix, which is when x equals a over e. So this will be equal to e times p to d, x minus a over e. And we can simplify this by squaring both sides to cancel out this square root. So now we get a to e minus x all squared plus the y squared will equal e squared lots of x minus a over e all squared. And we can expand out both pairs of brackets, so now we get a squared e squared minus 2ae x plus x squared plus the y squared will equal, we can expand out this bracket and then multiply it all by e squared, and this will give us e squared x squared minus 2aex plus a squared. Now you can see we can cancel this negative 2aex with this one, and we can begin to move all the x terms on one side of the equation. So we get x squared minus e squared x squared plus the y squared will equal a squared minus a squared e squared. So all I've done, I've moved this to the left hand side and this to the right hand side. Now we can factor out the x's and the a's. So we get x squared lots of 1 minus e squared plus the y squared will equal a squared lots of 1 minus e squared. So now you can see that we're starting to form this hyperbolic equation here. But we need to make the right hand side equal 1. So we'll divide both by a squared multiplied by 1 minus e squared. And when we do this with the x squared term, this will cancel with this. So we get x squared over a squared plus y squared over a squared 1 minus e squared, and this will equal 1. Okay, at this point we've got what could be the equation of an ellipse, because this is a positive and not a negative, but we can make this a negative by making this a negative, and then these two negatives will cancel. So we can have this as x squared over a squared minus y squared over a squared lots of e squared minus 1, and this will equal 1. So you can see then that this is our b squared term. So b squared will equal a squared lots of e squared minus 1. Okay. And in example 2, we're going to use this equation to find the Cartesian equation when we have its e value and foci. Okay, so in example 2, we've been told that hyperbola has eccentricity value and e value of 5/4, and its foci are plus or minus 15, 0. We've been asked to find its Cartesian equation, and we're going to use its formula here. So the first thing we need to think about is that its focus is at plus or minus AE and 0. And if we just consider a positive case, then AE will equal, in this case, 15. And we've been told that our E value is 5/4. So what we can do is we can substitute this value of E into here to find A. So 5A/4 will equal 15. We can multiply both by 4, divide by 5, so A will equal 12. Which means A squared will equal 144. And now to work out our B value, we know B squared will equal A squared, 144, over E squared, so 25/16, minus 1. We can write this one as 16/16, so this becomes B squared will equal 144 multiplied by 9/16. So B squared will equal 81. So the Cartesian equation is x squared over 144 minus y squared over 81 is equal to 1. Okay? Let's move on to question 3. Okay, so finally, for example 3, we've been given the general equation of a hyperbola. We've been told its foci lie at 5 and 0, plus or minus 5 and 0, and its directrices have equations x equals plus or minus 16/5. So we know the general equation for the focus is AE and 0, and for the directrix, x is approximately A/E. So this AE is given as 5 if we just consider a positive case. So AE equals 5, we'll call this equation 1, and A/E equals 16/5. And we'll call this equation 2. So if we make A the subject of equation 2, and then substitute that into here, we can find E. So from equation 2, A will equal 16E/5. Putting this into here now, we get 16E squared over 5 equals 5. So E squared will equal 25/16. So therefore, E will equal 5/4. Again, I'm just considering a positive case for now. So now we know E, we can substitute this back into equation 1 to work out A. So A times E, 5/4, will equal 5. We can cancel out these 5s and then move a 4 to the right-hand side. So A will equal 4. So therefore, A squared will equal 16. And finally, we can use the equation B squared equals A squared lots of E squared minus 1 to work out our B value. So B squared will equal 16 lots of E squared, 25/16 minus 1. When we expand out this bracket, these will cancel. So B squared will equal 25 and then minus 16. B squared will equal 9. So B will equal 3. Okay? Well, I hope you found that useful. And if you did find that useful, please like and subscribe. And you can download the full lesson and worksheet from our website, mrmathematics.com. There's a link in the description below. So thanks for watching and take care.